Hello, students. My name is Sonia Malik. I am your coding teacher and mentor. So, in this video, you will be seeing lot of expressions in C++, which will help you to solve plenty of coding problems, right? Okay. So, here is a list of all the expressions that I have covered for you in this video tutorial. Hello, students. In this lecture, we will be covering all the expressions in C++. So, what we will be covering? Expressions in C++ language. Okay. So, first expression is known as constant expression. I repeat, constant expressions. What are constants actually? What are constants? Constants can be your constant numbers like 1, 3, 4, like that, etc. 34, 567, etc. These are known as your constant numbered values, right? So, what are constant expressions? Calculations which are made using these constant is known as your constant expression. For example, let's say I'm writing 2 plus 3 by 5. Sorry. Suppose I'm writing 2 plus 3 by 5. This is your constant expression because it is made up of three constants. It is operating between three constants that are 2, 3, and 5. So the expression which is made up of constants is known as your constant expression. Another example I can give you is, let us say I have 3 minus 2 plus 5. Again, it is an expression which is made up of three constants. What are these three constants? 3, 2, and 5. If I'll give you more complex example of a constant expression, let us say I'm saying 2 into 3 plus 7 by 8 minus 9 into 7. This is also a complex constant expression. This is complex as per above two examples, but yeah, it is a constant expression because it is the expression that is made up of six constants that are 2, 3, 7, 8, 9, 7 again, right? It is made up of your six constants. So I hope you all are clear with constant expressions in C++. The expressions which includes constant, right? Okay. So let's move to second expression in C++. This is known as integral expressions. Yes. Integral expressions. What do you mean by integral expressions? It means if you change the data type at the time of displaying something. Integral expression means if you change the data type at the time of displaying. What I mean by this line? Suppose I am having char ch is equal to small a. I am having char ch. I have taken a character ch is equal to small a. I want to know the integral value of this small a. So what will I do? I'll do a cout and I'll use two parentheses. These are known as the round parentheses. In this, I'll write int. Int is the type in which I want to see this small a. I want to convert this small a into integral expression. That's why I wrote a int. Okay. And then what I can do, in another bracket I'll write this ch. Let us see what will be the result of this expression. Yeah, see on the screen, see on the output screen, it is giving you 97. So now you will ask me, like, what is this 97? This 97 is the sky value. I told you now that character can be represented in the terms of integer as per their sky value. Sky value of small a is 97. If I give a capital Z, capital Z, let us see what integral value will it give for this character. It is giving us 90. It is why it is giving us 90? Because range of sky for capital alphabets, capital alphabets ranges from 65 to 90, right? Where capital A is your 65 and 90 is your capital Z. Okay, so you have seen that how character Z can be represented into integral format. This is also known as typecasting. This is also known as typecasting. Typecasting means when you change the type of some data type. Here the data type originally was your character, but you converted this character into integer format. That's why it is known as typecasting. You have changed the type of the data, right, from character to integer. Okay. Another example for this integral expressions can be, suppose let's say, let me comment out this first. Suppose I am having int num is equal to 1112. Suppose I am having some integer data type with the value 112. I want to convert this integer data type into character. So what I'll do? Again the same format. I'll put a round braces and write the data type in which I want to see this 112. I want to see this 112 in the character format. In the character format. That's why I have put round braces, and inside that I have written character, and another braces for this num, what in which you want to convert and what you want to convert, right? If I'll print this, let us see what we will get. Cool, we have got a p. As you can see on the output screen, we have got a p. It means the sky value of that p is 112. That's why in character format it has given us small p, because small alphabets ranges from 97 to 125 and p falls within this range. So I have given the sky value of 112 in the integral format, and it has given me the character, right? Okay. Another example is, suppose you have a double data type and suppose you have given some 12.5, because you know that double stores the decimal values, right? So double num is equal to 12.5. Suppose I want to extract the integer part out of this 12.5. It means I want to take 12 out of it. So what I'll do, again the same format that I told you, round braces, in which data type you want to convert it. I want to convert it in integer format. Okay, integer format, right? Again a round parenthesis and writing num, because I want to convert num into integral format. Let me comment out the above one and we will see, like, what we will get, 12.5 or 12. Cool, cool. You can see that we have got 12 on the output screen. The decimal part is eliminated. Why it is eliminated? Because we have typecasted the double from we have typecasted from double to integer, right? If we wouldn't have done this typecasting, it will give us 12.5 only. Yeah, as you can see on the output screen, it is 12.5. But as we have typecasted, that's why it is giving us 12. The last example in this is, suppose I have taken int num is equal to 13. I want to typecast this in double format. So I'm writing double. What you want to typecast? Num variable. Let us print this and we will see something very surprising. It is 13 only. Now you will say that, okay, ma'am, it is not converted into 13 point something. Like it is integer only. It is not casted from integer to double. In double, if you typecast something from integer to double, it will internally get it like 13.0. Okay, 13 is converted to double. Yes, it is converted. But why you're not seeing on the output screen? It is because internally your computer computes 13 as 13.0 when it is typecasting to cast it to double. But it is not shown on the screen because point 0 has no value, right? Something as point 0 is not of very much significance. Point 0 has nothing. That's why it is not printing it. Point 0 gives us no value. That's why it is only printing 13, not 13.0, because 13 and 13.0 are same. That's why it is printing only integral value. So this is the exceptional case, like uh, even after typecasting from integer to double, we have got 13 only, because that point 0 is not visible, but it is internally interpreted by computer as 13.0, but it is not visible to us because 13 and 13 point something point 0 is same. Number point 0 is number only, right? Okay. So I hope you are all are aware of integral expressions by now. Okay, let us move to another expression, the third one. So, what is the third expression in C++ language? It is known as the float expressions. Yes, float expressions. So, you have studied about integral expressions where, or constant expressions where constants are used to form some expression. Here, what you will think, like what will be the definition of this float expressions? Float values are used to form float expressions, right? Why they are known as float expressions? Because here we will be using float values to form some expression. Suppose, for example, I have 3.5 plus 2.8. 3 plus 5, 3.5 plus 2.8. What it will give you? It will give you something like 6.3, I guess. 6.3, right? Okay, yes. So, float expression means where float values, no, these are the float values. 3.5 and 2.8 are the float values that are forming some expression. Okay. Another example for float value expression can be 3.5 into 2.8 modulo something. What we will do modulo with? Let us say 6.9. I'm not sure like what will be the value of this expression, but I want to say you that okay, this is also homework for you. Calculate the value of this expression, right? Okay, but my main intuition was to tell you that float expressions are those expressions where float values are used for computation purposes. Here we have three float values: 3.5, 2.8, and 6.9, right? Okay. So these are all your float expressions where float numbers combine to form some expressions to do some calculations. Okay. Let's move on to your fourth expression in C++. We call it as compound expressions. What we call it as compound expressions, right? Okay. So what do you mean by compound expression? It includes two signs. It includes, Now I am not gonna say like these are those expressions which are formed by some compounds. This is not a sensible definition. Not every time the definition is formed by the name itself, right? So it includes two signs. What are those two signs? Plus equal to and minus equal to, and also multiply, four signs basically: multiply equal to and divide equal to, right? Mainly it have these four signs. Now I will be telling you what type of calculation we can do by compound expression. Suppose I have some int num. Okay, let me demonstrate it using coding only. I have something as int num is equal to 10. I want to add 5 to this 10. 5 to this 10. So what I will do, num plus equal to 5. Wow, what just happened? I have added 5 to this num value which was 10. If I expand this expression, plus equals to will be like something like this: num is equal to num plus 5. You know, like how this plus equals to is opened, it is opened like that: num is equal to num plus 5. But in order to shorten it, we are writing num plus equals to. But okay, but if I expand this, it will be something like this. It means your 10 has gained the value 5. So what will it become? 15. Let us see running it on the compiler. Okay. Okay, let us check if it gives us 15 or not. Wow. Wow, it is giving us 15, right? Similarly, if I do a minus equal to, you tell me how this minus equal to will expand itself. It is num equal to num minus 5. Okay, let us print it if it will give us 5 or not. Yes, it is giving us 5. It means we have subtracted 10 from this 5. Minus equals to. Again, if we do a multiply equal to, if we do a multiply equal to 5, what it will give? I think it should give me something as 50, because 10 into 5 is 50. How it will expand itself? Num is equal to num into 5. Okay. Cool, cool. It is giving us 50, right? Now the last one is divide equal to. If I put a divide, I think it will give me something as 2. Okay. And how it will expand itself? How will it expand itself? Num is equal to num by 5. Num is equal to num by 5, right? And let us see what will be the value. Okay, cool. It is coming as 2. So your homework for this, a kind of, this is very, like, if I would say you, this is very much used in programming language. Like when you will be a coder, when you will program something, this will be used on a very urgent basis. This plus equals to, this is very much in demand, these compound expressions, and you can easily learn these four expressions. I have demonstrated how they worked, how they can be expanded, how plus equals to minus equals to can be expanded, right? Okay, I hope by now the compound expressions are clear to you guys. So let us move to the fifth expression in C++, which is known as relational expressions. Relational expressions, right? So what these relational expressions do? Yeah, they have a definition in their name. Yes, expressions which expresses relation between two numbers or decimal numbers or characters, right? They are those expressions which basically expresses relation between two numbers or decimal numbers or characters. In order to demonstrate you, let us move to the first example. Suppose I am saying 10 is greater than 2, which is correct. How 10 is related to 2? 10 is greater than 2. What kind of relationship they are having? Greater than. They are having a greater than relationship with each other. And if I say 2 is less than 10, yeah, 2 is less than 5, what kind of relationship 2 is having with 5? Less than relationship, because a less than sign is used here. Okay. And if I say 5 is less than equal to 5, what kind of relationship a 5 is having with itself? It is generally considered as less than equal to, not greater than equal to. 5 is either considered equal to 5 or less than. It is accepted by nature. Okay, less than equal to. This is having two relationship in one go, right? Okay. So it can be also greater than equal to kind of relationship also it can have. To demonstrate you something, suppose I am taking character ch is equal to small a and character ch is equal to small p, and I am writing a if condition. Again, I'm saying you don't worry about this if else condition, we will be covering in the further videos. Just focus on the logic what I'm saying. Okay, I'm saying, okay, let me give some other variable name for these two, otherwise this will be ambiguous. Ambiguous error is something when you have already declared it and you're again using the same name, right? Okay, I'm saying if ch1, let me comment, okay, no need to comment it off. If ch1 is less than ch2, then I will be outing that ch1 ch1 is less than ch2, right? Else ch2, I'm just printing something. Okay, let me run this code. It is saying a is less than p. A is less than p. It means a is sharing a less than relationship with p. Now you will say like why these ch1 and ch2 are not in parentheses, why only is less than? Because I want to hard codingly print that is less than thing, but already I have some variable name ch1, so I directly use it. When you have to hard code something, when you have to print something, then only you will apply parentheses. Otherwise, if something is given a name, if this a is given a name, then use ch1. Okay. Okay, so these are known as the relational expressions: less than equal to, greater than equal to, less than, greater than, like that. So I hope by this you will be like you and me are on the same page. You have got a clear idea about this relational expressions in C++. Next is we are having logical expressions. What we will be having? The I think sixth one, yeah. Sixth expression in C++ is your logical expressions. Logical expressions. What it will denote? What it will denote? Can you tell like what it will denote? Expressions which contains logics. These are those expressions which contains logics. Okay. What kind of logics? Suppose I have two things. Two things I have. Suppose I have two expressions. Suppose I have two expressions. It expresses the logics between these two expressions. Suppose I am having some ABC expression, and suppose I am having some DEF. I will give an example for this, don't worry. It will say both conditions are true. It has four scenarios. Both conditions are true. Both conditions are true. Both conditions should be true, not are true, should be true, like honi chahiye. Any one can be true. It is having this two possibility. If it is, there are two types of logical expressions actually. One is ampersand ampersand, another one is piping piping, pipe. Okay, these are the characters that is available on your laptop's keyboard. You can see, check them out. Okay, this and will represent, this ampersand ampersand will show that both expressions should be true. ABC also should be true, DEF also should be true. This piping represents that ABC can be true, DEF can be false. Like anyone should be true. Not, it is not compulsion that if I like tea, you also like tea. Okay. Suppose I'm applying this and this ampersand conditions in some real life. Someone is saying you should also like coffee. Your sister should also like coffee. He has implemented a condition upon both of us. It is not always true, na? Like if I like coffee, my sister will also like coffee. And another person is saying, hey, no worries. You can like coffee or your sister can like coffee. It is not a compulsion that you both should do the same thing. Anyone can do the same. Anyone can do this thing. Anyone can like coffee or tea. Not both. Not necessarily both. I would like to demonstrate you by giving example. Okay. Suppose I am giving an if else condition 10 greater than 2 and 5 greater than 2. See out true. See out a true. Else see out false. I have used ampersand operator between these two expressions. These two are constant expressions, right? I already told you, or relational expression or compound. You can, it's not compound, relational or constant. You can say anything, right? I have put ampersand. It means if both the expression will be true, then only I'll return a true. If any one of them is false, I'll not return a true. Ampersand means both should be true. Compulsorily, both should be true. Oh, I am not putting a semicolon, that's why. I'll make a separate video on various types of errors you can get while programming. It is giving us true. But if I write 5 less than 2, it will give us false because one condition is true, that is 10 is greater than 2 but not 5 is less than 2. One condition is true. But if I replace this and with or expression, it will give us true because any one is true. And that true one is anyone, like or expression gives us true if anyone is true. This is true, this is false. And or between true and false is true only, right? Okay. To simplify something, I would like to say something to you. See, you have true, it is always a true. If you're having true, false, are you aware of that chart? Are you aware of, let me erase it off. Are you aware of that chart of ampersand? It is similar to that. True plus true is true. Okay. False plus false is for sure false. True plus false is false. And false plus true is also false. It means ampersand only accept this condition when both are true. Otherwise, if anyone is false, it will give you false. If any expression is false out of these two. But this is not the case with or. Or behaves something differently. Let me copy paste. Suppose this is or. It says if both are true, both expressions are true, then also I'll give a true. If one is true, like in this third 15th line you can say one is true and another one is false. Your or will give a true here. Why? Because true says that anyone can be true. And same way in the 16th line, one is false, one is true. So your or will give a true because at least one among the two is true. But in the 14th line, when both are false, or operator is giving you false. Right? This is the table for how and will behave for two expressions, how or will behave for two expressions. Right? We will be seeing them a lot in if else conditions. Wait for the if else part to be taught. I hope you're clear with this logical expressions, right? Okay. So the next expression is your bitwise operator. Bitwise operator, not expressions. Okay. Expressions and operators are quite same. We will be covering all the operators in the next session. I will say that bitwise expression is not a very small topic. It is a very huge topic. Actually, it has lots and lots of operators contained within itself. So, I am thinking of covering this bitwise expressions in the next video. Like, I'll make a separate video for this bitwise operators so that you will be customizingly focusing on one topic, that is bitwise operator. So we will see this bitwise expression or bitwise operator in the one of the future sessions, right? Because it is very vast and I will not be covering in this video. Okay, so till then you can also google it up. You can google bitwise expression and uh, study something as a prerequisite before the original topic is taught to you. Okay, here we come to the end of session. I hope you have gained some knowledge about various expressions in C++ language. So I thank everybody for joining in and thank you for your time.